Hi, this is part 3 of my series on the mock exam for June. Um, I continued with part A already in the previous question. So I just want to bring the right hand side where it says that the left hand side is identical to 1 minus 10 square theta. And I want to take that 1 minus 10 square theta and I'm going to use it in my equation in part B because the left hand side is identical to that. So that's 1 minus 10 square theta. Now I'm going to let that equal to 2 10 to the power 4 theta. Also take note of our domain there. All right, so again, this gives you 2 10 to the power 4 theta plus 10 square theta minus 1 is equal to 0. Something else that I need to bring to your attention is that this is exactly the same as that. So this will be then written as 10 square theta or squared plus 10 square theta minus 1. The reason why I do that, I'm going to say let u equal to 10 square theta. Okay, so everywhere where I have a 10 square theta, I'm going to substitute it with u. Okay, like this. And I have a quadratic equation here that factorizes. Okay, so I hope you're familiar with factorizing. There's quadratic equation formula included in your list if you want to use the quadratic equation formula to solve this particular equation. So it's 2u minus 1 and the other one will be u plus 1. So 2u minus 1 is equal to 0, or u plus 1 is equal to 0. When you multiply the product of 0 and you get a product of 0, it implies that one or the other should equal to 0. So in this particular case, u is equal to a half, or u is equal to negative 1. But I'm not looking for u, so I'm going to replace my u with my 10 square theta. Okay, so I'm just going to do it under here. So that is 10 square theta equals to 1/2, or 10 square theta equals to negative 1. Now, in order for me to get rid of that square, I need to take the square root, which is a positive or negative number, of 0.5. But in this particular case, it will not work, okay, because you can't take the square root whether it's positive or negative of a negative number. So this particular one is therefore not going to be valid. So it's invalid, okay? So I'm only going to work with the one that is defined, and the one that is defined would be the tangent of this particular answer. So that gives me theta to be arctan, or inverse tangent, of the root 0.5. So I'm using the positive one to find my acute basic angle, and everything is in degrees, so make sure that your calculator is in degree mode. As you can see, mine is not, so I'm going to go shift setup and I'm going to choose 3 to have it in degree mode. All right, so that means the inverse tangent of the square root of 0.5 is going to give me the reference angle 35.3 to 1 decimal place. So 35.3 degrees. This is the acute basic angle. But looking at our domain from 0 to 180 degrees included, that means our solution can't obviously be in this quadrants. These quadrants are out, all right? But definitely theta is here, which is also a solution. So in the first quadrant, theta will equal to 35.3 degrees. And also in the second quadrant, okay, so in the second quadrant, because in the second quadrant you are saying that the angle is obtuse, and in that particular angle the ratio will be negative from our previous work there, square root. Good, so that means in the second quadrant theta will be 180 degrees minus 35.3 degrees, which will give you 144.7 degrees. So answer which rounds to any of those will therefore be acceptable. So our angle therefore is 35.3 and 144.7 degrees respectively. So that's the solution to that particular case, and as you can see, it is within our range of our given domain. Okay, so we are going now to the next question, question 12. So we have a diagram here, shows a sector. The sector is CAB, okay, which is part of a circle with center C. So the whole thing, is a sector of a circle. Now, you also supposed to be familiarizing yourself with some important formula, which you can find at the back of this of this document. So, in order to find the area of a sector, okay, the area of a sector, it's going to be a half theta times r squared. Okay. To find the arc length, you will find the arc length by saying theta times r. So please note this formula r on page 28 of this document. Right. So they want us to find the CD in terms of r and sine theta. So what we're looking for is this whole distance from C all the way down up to D. Now, it's not difficult to come across or to be able to see some. For example, this here should also be R because this is a radius, okay? That means that FO is equal to OD, which is equal to R. So this distance here will be R. So I have a part of it. Now, if you look at triangle FOC, you'll notice that this triangle is 90 degrees here because you have a radius to tangent scenario here. So this is a 90-degree angle, or pi upon 2. So if that is the case, then you can actually write that, you say that sin theta here, the sine of theta, is going to be whatever is opposite theta, in this case r, over the hypotenuse, which is OC. Because I need to know what OC is, so I can say OC plus r more gives me the distance of CD, okay, which is the required distance. So we just have to manipulate. Maybe you can make this like cross multiply. So this is OC sine of theta equals to r, given that then OC will be r over sine theta. Now I know that that is r over sine theta. So if that is the distance from there all the way up to there, then the whole distance will just be those two added together. So CD therefore will be r plus r over sine theta. All right, and they wanted the answer in terms of r and in terms of sine theta. That is what you do in that particular question. So this question is best solved by working through the problem on the diagram. Okay, let's go to the next question. So we know from our previous work that the distance of, I'm just going to write it here, of CD is r plus r over sin theta. Now they are saying r is 4 and theta is pi upon 6, which is like 30 degrees, okay, pi upon 6 radians. Now they want you to find the perimeter of CAB. Now, if this distance CD, and I need to bring that distance to you, distance CD is the same as distance AC, which is the same as BC, which would be this 4, which would be r plus r over sine theta. But we know what our r is. Our r is said to be 4, okay? And sine and theta is nothing but pi over 6. So we can actually calculate that. So that will be 4. Oh, so one more thing, your calculator therefore has to be in radian mode because the angle is in radians. 4 plus 4 over sin pi over 6. Pi over 6. Okay? That gives you 12. So that distance is 12. Suppose you did not change your calculator to radian mode and you still keep it in degree mode. Okay, so if it's still in degree mode, degree, then you must say 4 plus 4 upon sin. Now pi over 6 is nothing but 30 degrees, and I hope you know how to convert those things. You still get the same, but go ahead and let's keep our calculator in radian mode. All right, so that distance there is, again, as I said, that will be the distance, the whole distance there will be 12, because it's the same as that distance there. Also, that distance there will be 12. So that means I have the 24 already. So the only thing that I need is arc AB. Now remember what I said. If you don't remember how to find, because we're working with radians here, how to find the arc length, okay, then you go down to your formula list, you will find that it is also given to you there. Supposedly you forget those things, but it's very straightforward. You can always use your knowledge of degrees, and from there you do the conversion. But we're looking for distance, so the arc length, part of circumference. So if I look at page on my document, I think it's page 28, you will see that the formula to calculate the arc length is given by the radius multiplied by the angle. Radians times the angle. All right, that will be the arc length. Okay, so I'll go back to my problem because I'm looking for arc AB as an answer there. All right, so arc AB. So it will therefore be 24, because this is now what I'm referring to as the perimeter, right? So we're looking for this distance now. So that distance is going to be the angle theta times the radius times r. Now, what is the radius? Well, we know the radius is nothing but 12. Okay, so what is the angle now? The angle is this whole particular angle over here. That's what you need to understand. So we already know from the information given that this angle is pi over 6. So therefore this one is also pi over 6. So that whole angle will therefore be 2 times pi over 6. Alright, then you multiply that by the radius. Alright, so the perimeter will therefore be 24 plus these values that I have here, 2 times pi over 6 times 12. Okay. All right. So perimeter, therefore, in terms of they wanted perimeter in terms of pi. So your answer must be given in terms of pi. So I can just go clean it up and I say, okay, wait a minute. It's 24 plus now 12. 6 goes in there. 2 times 2 times 2 is 4. So the perimeter is 24 plus 4 pi. Okay. So that is the perimeter, and you have to be consistent, all right, with your working. Right, so I brought the diagrams over, as you can see. Maybe your diagram is not there, or it's just I don't want to go back and forth. So now we are asked to find the area of the shaded region, and then we must give our answer in terms of pi and root 3. So our answer should contain that. So there are many ways that one can do this. I'm going to start off by finding the area of FOC, which is that right angle triangle there. But then remember this was 4, and remember this was 4 over sine of pi over 6, which if you calculate, you realize it's 8. Okay. I hope you still remember from our previous work of the distance OC. So I'm just going to take you back to when we find OC. OC, we said, I think that we didn't calculate it here. OC is r over sine theta. So r over sine theta, which is 4 over sine of pi upon 6. Well, that gives you 8 if you punch it in your calculator. Okay, so that gives you 8. Right, what else do I have? So I also have an angle here. That angle there, so I know that this angle here is half pi radians, which is equivalent to 90 degrees. All right, that's half pi radians, which is 90 degrees. And that angle there was pi over 6, which is like 30 degrees. So this angle that I'm looking for, this one here, this is the angle that will be 60 degrees, or it's 60 degrees, or the angle is pi over 3 radians. Okay, I hope you should still remember how to find that. Okay, you can say pi over 2 minus pi over 6. You're going to get pi over 3. Why is that information important? Because now I'm sitting with a triangle. Okay, and I have a side 4, I have 8, and I have an angle, and the angle that I have is pi over 3. That's the angle. So what does it mean? I can therefore use the formula AB times the sine of C, of course, remember, multiply by a half. So it's a half times the distance 4 times 8 times the sine of pi over 3. Okay, so this obviously works out to something. So let's bring our calculator and find out what is our answer. So it's a half times 4 times 8 times the sine, okay, of pi over 3, which is like 60 degrees. Okay, right, so hit enter, I get 8 root 3. So the answer is 8 root 3. So that is just the area of half of these sort of the right angle triangle. Okay, so if I have to find double that, so if I have to quickly undo what I just did here, right? Just bring back, because I think I took away my sketch. Okay, right. So what I was thinking, okay, so right, there we go, technology. So the area now of the whole thing, because that was just one half, so the area of, if I say area of FO EC will be 2 times 8 root 3, which is nothing but 16 root 3. Okay, so I took care of that. Now what is the next step? All right, so the next step would now be for me to find the area of sector FOE. So I'm going to go to the next slide, okay? So I'm going to find the area of sector FOE. The area of sector FOE, if I just have to bring in a line here. So I'm looking for this sector here. So the formula to calculate the area of a sector, all right, is a half times the angle times r squared. What is r? R is 4. Now I'm looking for this angle over here. So I know that from my previous work that this angle here was pi over 3. All right, so this one here was also pi over 3. So I can find that whole thing there. So the area, the formula will therefore be a half times, that is 2 times pi over 3, and the radius is 4 squared. Okay, right, so I'm going to punch that in on the calculator and see what it gives me. So that's going to give me the area of that sector there. So what I do is my previous answer with this answer, I subtract them. All right, so it's going to be a half multiplied by 2 times pi over 3 times 4 squared. Voila. So I've got 16 upon 3 pi. So it's 16 pi over 3. So that's the area of that sector there. Now I have the area of the sector. I have the area of that whole sort of, what you call it, that whole kite there. So in order for me to find the shaded part, I will be subtracting. So the shaded region will therefore be that answer that I have previous, the 16 root 3 minus. So area of shaded part or shaded area is going to be 16 root 3 minus 16 pi over 3. And that's it, because you are supposed to leave your answer in terms of pi and in terms of root 3. That's 16. Okay, so again, as I said, there are many alternative methods that you can use. This is just but one of them in order for you to arrive at that particular answer. Right, so maybe I will also write another alternative method down for you, and then maybe you will see how I managed to get to it. So you can also say FC will be the square root of our OC squared minus 4 squared, which you know that from our previous work, OC is 8. So 8 squared minus 4 squared, that gives you 48, root 48, or that gives you 4 times that. Okay, now you can then also say, okay, therefore the area of FOC, right, which is going to be a half times 4 root 3, that gives you 8 root 3. So that is going to be now the area of half a sector. So double that, okay? So double, so that is FOC. So if I go back to my diagram, remember, FOC is just this one right angle triangle. So double that to give me FOEC, like what I did previously. So double, or area area of double area of OC will therefore be 2 times 8 root 3, which gives me that same 16 root 3. Okay, then you can say the next thing that you do, you can say the area of half a sector. Doesn't have to be a complete sector. You will say a half times pi over 3 times 4 squared. Well, that gives you 8 pi over 3. Okay, so half a sector, remember, it's still the sector here that I was using. Okay, FOE, but just half of it. So double it, so double that. So you can say, okay, well, double will be double of the area of that sector will be 2 times a half times by, or just take that answer that we have and you just multiply that answer by 2. So times 8, that is that, say times 8 pi over 3. Well, this will give you 16 pi over 3. Now you have this sector, you have that sort of what you call it, the kite, and then you can say area of shaded part. Then you can say, oh, shaded area will simply be the bigger value, 16 root 3, minus 16 pi over 3. And it's also going to bring you more or less to the same answer. Not more or less, but exactly to the same answer. There's many ways, but these two are the alternative methods. All right, so that brings me to question 13. Question 13, they are saying in the diagram, the lower curve has an equation y equals to cos theta, as you can see. The upper curve has the result of applying a combination of transformations to y equals cos theta. First, find in terms of theta, in terms of cosine function, rather, the equation of the upper curve. Okay, so let's look at the equation of the upper curve. So you see that curve, the cosine curve, has a complete cycle, like you can see under, every 2 pi radians, or every 360 degrees. So the complete curve here is every 4 pi radians, okay, which is like 720 degrees. Now, so the period of a cosine function repeats itself after every 360 degrees, okay, or 2 pi upon b. Now, what is my b value here? Well, I can clearly see that my B value is nothing but 4 pi. If I was to use that, I would say 720 degrees. Right, so if I clean this up, I'm going to get a half because the pi is cancelled and 2 over 4 is a half. So my period then, because the question is asking us also to write down a few things. So the period would be 2 pi over 4 pi, which is a half. Okay, so that takes care of that part. The next thing that I want to find is what we refer to as the amplitude. Okay, the amplitude. The amplitude is calculated by taking the maximum value, which is whatever it is, minus the minimum value. In this case, the maximum value, looking at the graph, is 5, that's the maximum value, and the lowest value is 1, looking at that graph there, okay, the upper curve. So 5 minus 1, and 5 minus 1 is 4, and half of 4 would be 2. So the amplitude is 2, all right? So I know the two values. Now, the next thing that is very important for you is how did this graph go upwards? All right, so I always ask people to find the center line. Now, the center line, I have some notes also below that you'll see when we sketch the other graph. The center line lies between the maximum and the minimum value. All right, so what does it mean? When you add, you say 5 plus 1 and you divide that by 2, you get your center line. That center line is the vertical distance that we are talking about. Okay, it affects the vertical distance. I just want to bring in a line here. Okay, maybe medium type of line. Maybe medium line. And oh my goodness, I was looking for a broken line. Okay, so 3, this line here, that is how it's between the minimum and the maximum. That is the vertical translation of the graph. You get it? So that 3 is very important that you had to calculate it. Again, how do you find it? You take your maximum value, your minimum value, you add them, and then you divide by 2. Find the mean. Okay, that 3 is important. So now I can actually go ahead and say, because the general form of this graph is in the form y equals to, I'm going to have a cos b theta or x, all right, plus c. The c affects the vertical distance. Are you with me? The b is the period, which we already discovered. The a is your amplitude. Amplitude is a positive distance, can be negative, but you might at times have a negative. That means the graph has been reflected, okay, flipped. So in this particular case, I can actually write my function as, what is the amplitude? The amplitude is 2, so it's 2 cos, what is the period? It's a half theta, okay, you can put it in brackets if you want to. And what is our vertical, the effect of vertical? It's plus 3. And this is how you find that equation. That's the equation of the curve on top there. So the equation of the curve is nothing but, if I have to write it, y equals to 2, then you have cos a half theta plus 3. Now, if they ask you to write it in different forms, yeah, it's also the same thing. You might see things like this. Y equals to 3 plus 2 cos half theta. It's exactly the same thing. All right, I hope that takes care of that. So apply your knowledge. We'll sketch another function and then I'll give you some hints so you can know what to do when you sketch a graph. Right, this brings me to question 14. So when you look at question 14, perhaps I hope you're familiar with the inverse of your functions, the transformations. All right. I'll also maybe advise you to go to a page in your textbook 206. This is actually a try now 54. Okay. This is the book Y equals mx plus c for the AS level in Namibia. But wherever you are in the world, you should also be able to solve this. Again, switch. That means you're going to say sine of pi over 6 equals to 4x to the power 4 plus x squared. Okay, right. This is something that you can calculate. Now, I hope you are familiar with how to find this. This is actually a half. You can punch that on your calculator if you're a bit unsure. So my calculator is already in radian mode. So the sine of 30 degrees pi over 6 is 1/2. Okay, I hope you are also, you know exactly your special triangles. Right, so our objective is solve this equation. So you can easily solve this equation. There are many ways that you can solve this equation. Suggest maybe you get rid of that 2 under because you don't like to work. So you're going to say multiply each term by 2. Okay, so that's going to be 1. That's going to be 8x to the power 4 plus 2x squared. You see that? Okay. And then you can go ahead and rewrite it as 8x to the power 4 plus 2x squared minus 1 is equal to 0. Again, remember that x to the power 4 is nothing but x squared squared. So you can actually say let u equals to x squared. But I'm not going to take that route. I can actually factorize this as it is. All right. So, but you can do that because it might look a bit too messy. All right. So this can actually be split, as I was saying. So everywhere now where you have your x squared, you're going to replace it with u. Okay. So it's 8u squared plus 2u minus 1 is equal to 0. And this should definitely factorize. You can use quadratic equation if you want to go that way. So it's going to be 4u minus 1 in one bracket and 2u plus 1 in the other bracket. Okay, plus 1 equals to 0. Right, so we can solve for u and then we put back our values. So this is going to be u equals to 1/4 or u equals to negative 1/2. I hope by now you are fine. Okay, so I'm going to replace my u with my x squared or x squared. But this one won't work because you have to get rid of that square by taking the square root. So this one is not going to be valid, not applicable. So we are only going to work with x is the square root, positive or negative, of 1/4, which is the same as the positive or negative square root of 1 over the square root of 4. Therefore, the answer will be positive or negative 1/2. Okay, and those are the solution. Now you can go and write it nicely and say x equals to 1/2, comma, negative 1/2. That is the solution to your equation. All right, step by step. So at the end of the day, it's just some hidden quadratics, some sort. And again, remember you have your formulas if you forget how to solve quadratic equations and the likes. Okay. Now we get to question 15, which is also our last question in this series. So what they're asking us here is they want us to sketch the graph. The information is all the way somewhere. Let's say, just take the question. So we're supposed to sketch the graph of y equals to 3 minus cos 3x for between 0 for theta or x between 0 and 360 degrees, stating the amplitude and period, stating the amplitude and period. Good, typo. Now, there are a few pointers here that I have sort of typed for you, so you can just remember what to do in an examination when you sketch graph. So use a pencil and a ruler, and if it's not drawn for you, the x and the y axis, then you will have best to have them 10 centimeters, like 10 centimeters either direction, and 10 centimeters there. So in this particular case, we can go ahead and also label our axis. So this is the y-axis, and the one under here is the x-axis. Okay. And then the second step there, it says you are supposed to determine and write down the important features of the sketch, the maximum and minimum points of the function. Now, I hope you also know how to find them. And then the x-intercept and y-intercept. There is only one y-intercept of the graph. Sometimes the graph may not intersect at the x-axis, like you will see with this graph, for example. And the period, like what I did when I calculated the other graph, the previous question. Then the amplitude, the height from the center line. The amplitude, I gave you the formula here, the absolute value of the maximum minus the minimum, half of it. And I also included so you can see how to find the center line, because the center line is very important. One of the things also that you should remember is that the amplitude is a distance, so it will always be a positive number. So when they ask you to write down the amplitude, you can't write a negative, okay? Even the sign in front of the amplitude, if it's negative, it means the graph has just been reflected in the x-axis. Like this particular one here, because you see that there's a minus in front of that cos there, which means the amplitude can actually be seen there as 1, positive 1. And then the last part here, if you are talking about asymptotes, is when we are dealing with tangent graphs, but this is not a tangent graph. So we plot all of the information and then we go from there. So let's see. So first of all, what is it that we can decipher from this? Well, we can decipher that the amplitude, well, this is a seen thing, is that value in front of that. So I'm going to write it here. The amplitude is positive 1. Remember, I just said that the amplitude has to be positive 1. And the period now, this is in degrees. The period is going to be, the cosine graph repeats itself after every 360 degrees. So you divide that by that 3 that is there. So the graph will repeat itself after every 120 degrees. Okay, so we have now the amplitude and we have the period. So that's already like 3 marks for saying that. So I'm just going to write down what I have so far. So the amplitude is equal to 1, and the period was 360 divided by 3, or 120 degrees. Good. Then one of the things you should also know is the maximum. And I'm going to write that down here. The maximum is calculated by taking your A plus your C, and the minimum is calculated by saying minus A plus C. Okay. You can check this information. You know you by now how that works. Right. What is our value of A? So let's go back to the graph. Our value of A, remember, our C is 3, and our A will be whatever the amplitude is, right? So the maximum then would be 1. So let me just go back to that information where I wrote it. Okay. So it will be 1. That is what my A is. Okay. And my C was 3. Okay. That 3 is coming from the information all the way up here. Okay. All right. That 3 that is there. All right. Good. So it affects the vertical transformation. So here I'm going to have A is 1 plus 3. So the maximum will be 4. Here I'm going to have negative 1 plus 3 is going to be 2. Okay, so that's my maximum and minimum. What else do I need? Maybe perhaps you also need the center line. And remember what I said, how do you find the center line? You add your maximum and your minimum, and you find the mean, okay? So the center line, 4 plus 2, 6 is going to be a 3. Right, why is that important? Because now, if I have to fill in my information, so first of all, here, I'm going to go all the way, maybe I say that's 1, that's 2, that's 3, that's 4, 5, maybe 6. I know my maximum value is 4, okay? So I'm going to bring in my center line, and you take your center line, which I said is going to be a 3, and that's where my center line is, okay? My maximum is 4, my minimum is 2. So the graph, in fact, if I can just change it, my graph is going to oscillate between 2 and 4. So I'm just going to do that as well there and as well there. So use your ruler and you can do that. Okay, what other information do I need to know? Well, I know that the graph repeats itself after every 120 degrees. So I'm going to divide my x's at the bottom. So that's going to be 120, and that's going to be 240, for example. Okay, so you are adding 120 every time, and that is going to be 360. Because you're supposed to sketch this between 0 and 360. Okay, right, don't be afraid to draw yourselves lines, like if you want to. All right, so I just don't want to bring in those vertical lines. I think I should be fine. So I know my graph is going to be in that between those maximum and minimum. Okay, so this is the max, this is the center line, and that's the minimum. Are we clear? Right, so I need points. Right, I know that if to draw a graph, and I'll show you this little trick here. Okay, so I know that, okay, my period is 120. So take that and find what I call key points. And the key points, you take that 120 and you maybe divide it by 4. Okay, so that means it gives you an indication of your angles that you can have, maybe. All right, so 30 degrees, 60 degrees, you understand, 120. If you add, so that's like 30, that's 60, add another 30 degrees, 90. Maybe I went too far out, so let's say 90. Let me move a little bit this one. I don't want to add so many angles in between. All right, but then I'm going to take half, so here it's going to be halfway, so just add 60, that's going to be 180. And then here, if you add another 60, that's probably going to give what, 300? Okay, because it's 300 degrees, so that's halfway, right? So I can have values here and here, but I just don't need all those angles. But you can go ahead and continue. So 120, this is 150. 180, this is 210. 240, add another 30, that's 270. And then that is 330. All right, so what does it mean? Now I can have my points. Whenever you want now to know more or less where your values will lie, okay, you can actually grab your calculator and see what is the output. Now you see this function, I'm going to write it here because it's y equals to minus cos 3x plus 3. Okay, I'm going to put that on the calculator. So if this is what you do, you don't have to, but and one more thing, I also know that this graph is reflected. Normally the cosine graph goes that way, so this one is going to go the other way, like so. All right, so I'm going to take that and I'm going to bring in my calculator, and this is also something you can use with the calculators that are allowed in the examination. So what do? There's a table function. You go to 7, table function, and I'm going to put this function there. So I'm going to say minus cos of 3 alpha x, good, close it, plus 3 equal to, well, I'm not going to put the second function in there, okay? But if you want to, you can put the normal cosine function, but I'm just going to press equal to. So I'm going to start at 0 degrees, and I'm going to end at 360 degrees. Okay, and I want it to be in 30-degree sort of increments or intervals. Are you with me? Right, now I can actually find if x is 0. Can you see? This is the x-axis and that is the y-axis, okay? So if x is 0, then the y value is 2. So I'm just going to bring that down, bring my calculator back up. If x is 0, y is 2. Okay, so that is this point here. Maybe I must use a different color just to show you x0, that is 2. So that is the point I'm referring to. Let me just bring this up a little bit. Okay, bring my calculator back to find the other values, because it's very important that you get those key points in order for you to be able to sketch that. Okay, where are we at? Bring my calculator back. So there you go. If x is 30 degrees, I get a 3. Okay, so 30 is 3, 60 is 4. Okay, 30, it's 3, somewhere there. 60, it's 4, somewhere there. When you go back to your calculator and you go back down, 90, you'll see it's 3 again, and 120 is 2 again. So 90 will be 3, and that will be 2 again. So this graph is going this direction. And so you can continue. You can continue and you can have all those key points. Okay. I'll bring back my values. So I want to find 150 is 3. 180 is 4. 150. 150 is 3. So it goes back. 180 is 4. 210, you will see it comes back. 210, it will be back at 3. 240 will be there again. 270, it will go back at 3. 300 will be all the way at 4. 330, it will come back here. And 360 will be back here. So I've got my points. Okay, so maybe I'm just going to show you so you can see. 180, 180. So let me just move it aside. So 180, you can see 180. I'm all the way up to 4. Can you see that? 210, 3. Can you see that? And 242. Okay, I hope you can see. And 270 is 3. 300 is 4. 330 is 3. And 360. There you go. So those are ways you can find those points, right? You don't have to have so many points, but definitely it will assist you. So now you just go ahead and you draw those points. Okay, so my graph is a little bit out there. Let's start again. Don't worry if your curve is not too perfect though. So it oscillates, between those points. Oopsie. Let me just... now I took everything away. My goodness. But you get the idea. So take a little rest. So what you do is you have a paper. You have a paper, and obviously you have a paper, and obviously you can turn your paper around, so it's not going to be so difficult. Like now, I'm trying to move in my graph amongst those points there, but you get the idea. All right, so it's a little bit horrible sketch, but what I was looking for is something that goes from here all the way there, all the way here, all the way there, all the way here, all the way there. You get the idea. Okay, and so my graph will take shape. All right, so nice curve, play around with it nicely. Oops. Yeah, well, I won't rest until... So sometimes what I like to do, I also like to make vertical lines so that it's a little bit easy for me to sort of do this. So I'm just going to do vertical lines. So maybe here, 120, 240, and 360. Okay, so I know now, okay, it has to be amongst there. Go all the way up, comes down, all the way up, comes down, all the way up, comes down. All right, something like that. And of course, once you're done with it, then you are going to label your graph. You say this is the graph of y equals to, of course, it's 3 minus cos of 3x. All right, and that is how you sketch that graph. Okay, just do a better job of me, and I'm trying very hard to work with the stylus here, but yeah, it will still be a perfect thing. You take your paper, so you can use the inside of your palm in order to make those nice waves. All right, so I hope this has been very helpful, and also it allowed you to come across and see where you need to work on pay more attention on certain things, and use this format whenever you prepare. So I'm going to give work and do videos later in the week on integration. So I'm going to take exam style questions and as well as the ones that were written and in last year's paper. And I'm also going to do vectors, and I'm going to upload those videos, and then we are done with team one. And then I'm going to set up the paper of last year. But I have answered so many of the questions on last year's paper in my videos, but I'm going to do have a complete um, solution of the paper. And then we go on next term and we do the same for theme 2. So before you write the exam, then we have covered the whole work. Till next time, do take care.